Hi students, as a part of conducting polymers, today I am going to explain you about the doping of conducting polymers. So what is doping? Already we are well versed. That is, doping is nothing but the addition of impurities. So addition of impurities to the conductor to enhance or increase the conductivity of the conductor. So now we are going to discuss about how we can enhance or increase the conductivity of conducting polymers. So whatever the mechanism I am going to explain you, that is whatever the doping mechanism which I am going to explain you in this particular video to enhance or increase the conductivity of the polyacetylene is applicable to all the other conducting polymers also, right? So accordingly, the polyacetylene has been chosen as the example in order to explain the conductivity, in order to explain the doping phenomena, right? So accordingly, we are going to discuss about the doping of polyacetylene, and this is applicable to all the other conducting polymers also. In this manner only the doping of all the other conducting polymers is being done. So it is not only applicable to polyacetylene, but for exemplifying, I am considering the polyacetylene as an example. Right. So now, before going to start the doping of the conducting polymer, that is the polyacetylene, I would like to state one thing for you, that so the doping phenomena is actually explained by the physics concept such as the conduction bond, valence bond, the Fermi energy level gap, all that stuff. But I am going to explain this particular doping of the conducting polymer in terms of chemistry language only, pure chemistry language only. I am not going to use any conduction band, valency band, Fermi energy gap level. So many other faculties will discuss even the doping of the conducting polymers by that particular phenomena, but now I'm not going to explain to you with the help of that particular physics concept. So this particular video is purely made in the chemistry language only. So keep this in mind. Right, now, so basically we have the two types of dopings by which we can enhance or increase the conductance of conducting polymers. The one is P-type doping and the second one is N-type doping. So first and foremost, let us discuss about the P-type doping. So P in the P-type doping represents positive doping. Positive doping. Yes, P-type doping. P stands for positive. Positive doping. So what do you mean by positive doping? That is, positive agent is being added to the conducting polymer. In this case, positive agent is added to the polyacetylene. So what do you mean by positive agent? Positive agent means addition of electron deficient species to the polyacetylene. Addition of electron deficient species to the conducting. So addition of electron deficient species like all the Lewis acids or the electron deficient species, right? So with the help of the Lewis acids, iodine, we can enhance or increase the conductance of the polyacetylene. Right. Now this particular P-type doping involves the usage of either the Lewis acids or the iodine. Now these Lewis acids are electron deficient. Since these are electron deficient, they will try to grab the electrons from the conducting polymer. They will try to grab the electrons from the conducting polymer because these are electron deficient species. None of the substance wants to be in the electron deficient form or in the electron deficient form. It wants to be in the neutral form, right? So since it is electron deficient, in order to get stabilized, what it will do, this p-type doping agent, that is either the Lewis acid or the iodine, will grab one of the electron from the polyacetylene or any of the conducting polymer. Now the loss of electrons takes place from the conducting polymer. Now loss of electron is nothing but oxidation. Already we know that. Now what this particular Lewis acid iodine, that is the p-type doping agents are doing, they are oxidizing the conducting polymer. So since these are oxidizing the conducting polymer, the p-type doping is also called as oxidative doping. P-type doping is also called as oxidative doping because these p-type doping agents are grabbing the electrons from the conducting polymer in order to get stabilized themselves. Now what happens is the loss of electrons takes place from the conducting polymer, and the loss of electron is nothing but the oxidation. Now since these p-type doping agents are resulting in the oxidation of the conducting polymers, this p-type doping is also called as oxidative doping. I hope you got it. Oxidative doping. Now what is the structure of polyacetylene? I have clearly explained in the previous video. So if you want, I will give the link of it. So the link of that particular video is being provided in the description. So in order to know the structure of the polyacetylene, please do watch that video, that is which I have made on conductance of the polyacetylene. You can watch it. So this is the structure of the polyacetylene. So this polyacetylene comprises the alternate double bonds. Already we know that. Alternate double bonds. Now this p-type doping can occurs either in presence of Lewis acids or iodine. Already I have explained. So iodine I have taken. Now what I'm doing is we know that bond is formed by the combination of two electrons. Bond is formed by the combination of two electrons. Right. Now since bond is formed by the combination of two electrons, now instead of mentioning one bond, so this will happen with all the other bonds in the polyacetylene, but in order to specify, I am considering one of the bond. Now instead of mentioning one of the double bond, I will label them with the dots. Label them with the dots. I will label them with the dots. The combination, what are these dots? Dots are nothing but the electrons. Now the combination of the electrons is nothing but the bond. So instead of that bond, I have mentioned the electron. That is the case. I have not done anything. Now, in the presence of the oxidizing agent, already I have discussed oxidizing agent because it is electron deficient species. Now what it will do, it grabs one of the electron from the conducting polymer. Here the conducting polymer is polyacetylene. So this will grab one of the electron. Let us say that it is grabbing this electron towards itself. Now it is losing the electron. So now I am not disturbing the structure. So I am disturbing only this particular bond. So in order to simplify, I will label the bonds. I will label the carbons 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. Now, one of the electron from fourth carbon is moving towards this oxidizing agent. Now, this electron has been lost from the fourth carbon. Now, since the electron has been lost from the fourth carbon, electron has been lost means what? It has lost the negatively charged species, because electron is a negatively charged species. So since it is losing the negatively charged species, what will be the resulting charge on that particular fourth carbon? Positive. So it will get positive charge. The fourth carbon will get the positive charge. Fourth carbon will get the positive charge. Now fifth carbon, already there is no change in the fifth carbon, students. There is no change in the fifth carbon. Electron is present. Electron is present. So now, this is the case with all the other double bonds also, students. This is not only the case with the double bond which is there between the fourth and fifth carbon, but specifically I am taking the fourth and fifth bond. That is, whatever the double bond which is there between the fourth and fifth carbon, I am emphasizing on it. So this will happen in the other double bonds also, because it is a polymer. Since it is a polymer, it comprises so many n number of double bonds, alternate double. No. So this structure is resulted with positive charge on carbon and one of the electron is present. So this structure is called as polaron. This structure is called as polaron, students. This structure is called as polaron. Polaron or radical cation, because single electron is nothing but radical. So this is radical and this is cation. So it is also called as radical. Now, the radical cation has been formed, students. Now, what for we are doing this particular process? Why we are adding the iodine to this? Iodine is the oxidizing agent. So since it is oxidizing agent, it is grabbing one of the electron from the polyacetylene. The loss of electrons in the polyacetylene is taking place. During this process, since the loss of electrons is taking place, the polyacetylene is undergoing oxidation, resulting in the formation of the polaron or radical cation. Why we have done all this? Just in order to enhance or increase the conductivity of this polyacetylene. Now, how the conductivity of polyacetylene is being increased when the normal polyacetylene is being converted into the polaron or radical cation? Because we are well versed that carbon is neither most electronegative atom to bear the negative charge on it, or neither it is least electropositive to bear the positive charge on it. So the carbon cannot bear the positive charge on it nor the negative charge. It wants to be in the negative form. So it wants to be in the neutral form. But here the positive charge has been resulted on the carbon. Now such a structure is unstable structure. So since it is unstable structure, what will happen, students? The adjacent double bond will try to move towards the positively charged carbon atom. The adjacent pi electrons will move towards the positively charged carbon atom. Now, this movement is very fast. Why it is very fast? Initially, there was the polyacetylene with the normal alternate double bonds, but it was not unstable. It was stable, but it has been destabilized whenever it is treated with iodine. It has been converted into the polaron, which is a radical cation, and this radical cation carries the positive charge on the carbon atom. Hence, this polaron is an unstable structure. So since it is unstable structure, in order to stabilize the structure, the electrons will move fastly towards the positively charged carbon atom. Now, faster the movement, greater is the conductivity. Faster the movement of charge carriers, greater is the conductivity of the substance. So this is how, due to the formation of unstable structure, the charge carriers are moving faster. So thereby conductivity of this conducting polymer is increased. So somehow it is okay. The electrons move faster in this. But here, what happens is, the reaction will not stop once the polarine has been formed. Now, the same thing. Happens. So, polarine, radical, cation, right? Radical, cation. Now, this react with another iodine molecule. This react with another iodine molecule. Now, this another iodine molecule, what it will do is, it will grab this electron. It will grab this electron also. Now, already positive charge is there at 4th carbon, right? So, once again I will label it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4th carbon, positive charge is there, 4th carbon. Now it is grabbing this electron also. So what is happening? At the 5th carbon also, positive charge is resulted. The carbon also, positive charge has been resulted. Now this structure is nothing but the bipolar, because two cations are formed. It is nothing but bipolar. Now this particular bipolar is highly unstable molecule. Why it is highly unstable molecule? Because the carbon already have said that it cannot bear the positive charge, but here two positive charges are there adjacent to each other. So just imagine the stability of this bipolar. It is highly unstable. So since it is highly unstable, in order to stabilize this positively charged carbon atoms which are adjacent to each other, the electrons move very fast when compared to the polar. So here the electrons movement is faster, whereas the electrons movement in the bipolar is fastest. Fastest. So fastest is the movement. Definitely the conductivity will increase many times. I hope you got it. So this is about the p-type doping or oxidative doping strokes. Oxidative doping. Now, so let us label 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, students, every faculty, I believe that other than me, every faculty will explain with the help of conduction band and the valence band. So they will simply say that during the p-type doping or oxidative doping, holes are generated. So since holes are generated, the Fermi energy level gap between the conduction band and the valence band is reduced, so by which the conductance increases. Simply. But this is what exactly happens. So that is the reason at the beginning of this class only I have clearly explained to you that I'm not going to explain this concept in physics language. Instead, I'm going to explain this concept in chemistry language, because this is a part of chemistry. We have to discuss in the terms of chemistry language only. Now, the next type of doping is N-type doping or reductive doping. N-type doping is nothing but the addition of the negatively charged agents. Negatively charged agents means the addition of electron efficient species. Electron efficient species. Examples of electron efficient species means what? Lewis base. So Lewis bases are the examples of this N-type doping. And what this electron efficient species or negatively charged species will do? They will what they will do, students? They will reduce this particular polyacetylene. They will reduce means they will add the electrons to the polyacetylene or any of the conducting polymers, because they are electron efficient. So since they are electron efficient, already I have discussed, none of the substance wants to be in the electron deficient form or electron efficient form. Every substance wants to be in the neutral form only. Now it is electron efficient. So in order to get stabilized, what it will do? It will give the electron to the conducting polymer. Whenever it is giving the electron to the conducting polymer, so the conducting polymer will gain the electrons. Now gaining the electron is nothing but what? Reduction. Now as this negative agents or N-type doping agents are facilitating the reduction of conducting polymer, this particular N-type doping or negative doping is also called as reductive doping. Reductive doping, because they are facilitating the reduction of the conducting polymer, in this case polyacetylene. So what they will do? They will supply the electrons. They will supply them. So in a simpler fashion, I am taking the fourth and the fifth one only. So electron present at fourth, electron present at fifth. Just what I'm doing nothing. Just instead of the bond, as the combination of the two electrons is a bond, instead of the bond I have placed the two electrons. That's it. Now the most appropriate reducing agent for enhancing or increasing the conductivity of polyacetylene is sodium naphthalide. Sodium naphthalide, which is Na plus C10H8 minus. So what it will do? It will provide its electron to one electron of this. So now what happens, students? So let this particular electron, fifth electron, is intact like that only, but this electron is gaining one more electron, because it is facilitating the electrons. It is facilitating the reduction, already I have discussed. It is supplying the electron to it. Now this electron already there. Now due to the gaining of electron, this negatively charged electron becomes negative totally. So it becomes negative. Becomes negative. So it is negative now. Now already I have discussed that carbon is neither electron efficient to bear the negative charge nor electron deficient to bear the positive charge. So since the carbon is neither electron efficient to bear the negative charge, this particular molecule which has been formed is not stable, because the negatively charged carbon is present. It is not stable. So in order to stabilize, what happens is, negative charge is present in the carbon means what, students? Extra electrons on the carbon are present. So extra electrons are present on the carbon. So extra electrons. So if it gives the extra electrons inside the chain, then what happens? It gets stabilized. by which the whole molecule gets stabilized. So what it will do now? This negatively charged carbon will enter into the chain rapidly, by which the movement of electrons, movement of pi electrons becomes very fast. So movement of electrons is fast. Same conductance. So moreover, another electron is also there. Another electron is also there, students. So this fourth has become negative. Fifth is there. This reacts with another moiety of this particular reducing agent, sodium naphthalide. So now it donates its electrons to the fifth carbon also, by which so fourth carbon already became negative in the first step. Now by the supply of another electron from the sodium naphthalide, which is the reducing agent, this fifth carbon also gets a negative charge. Now two negative charges are there adjacently. So when two negative charges are present adjacently, that particular structure is highly unstable. So since it is highly unstable, in order to become more stable, so do remember, students, that every substance, whether it is the living organism or non-living organism, so it wants to be in the stable form only. So this particular molecule is not stable. Since it is not stable, what happens? So negative charge is present on the carbon, means extra electrons are present on the carbon. So if it loses the extra electrons, then it will attain the stability. When the carbon attains the stability, so definitely the whole molecule attains the stability. So for which this negatively charged electron, that is extra electrons present on fourth carbon, extra electrons present on fifth carbon. So what they will do is they will enter inside the polyacetylene chain rapidly, facilitating the rapid movement or fastest movement of the electrons inside the polyacetylene, by which there is a enhancement or increase in the conductivity of the conducting polymer. Any conducting polymer, the mechanism is one and same. So in order to exemplify, I have taken the polyacetylene as an example. I hope you understood this. So simply what the other faculty will do, just what is happening here. So negative charge has been generated. Since negative charge has been generated, the electrons are increased. So since the electrons are increased, the Fermi energy level gap between conduction band and the valence band is decreased, by which there is an enhancement or increase of conductance of conducting. But this is how exactly we have to explain the conductivity of conducting polymers, because it is chemistry, not the physics. I hope you got it.